In today's physics class, we shall be solving this problem. The question says, in the diagram below, if m1 is 5 kg, m2 is 2 kg, calculate the acceleration in the system, assuming there is no friction, and also calculate the acceleration, assuming there is friction. Take the coefficient of friction to be 0.2. Now, to solve this problem, the first thing you should think about is to understand which of the masses is greater than the other. So between M1 and M2, who is higher? So you can see that M1 is 5 kg and M2 is 2 kg. Definitely M1 is greater than M2. So which means that our acceleration will be the weight of the one that is the highest, which is the weight of M1 minus the weight of M2 divided by the sum of their masses, which is M1 plus M2. So we have already established that in our previous video. So if we put that together, we know that the first question, since they said there's no friction, so we are going to work with that. So assuming there is friction, we are going to include friction in this formula. So to solve the first problem, we will say acceleration will be, the formula it was derived as the weight of m1 is given as m1 g sine theta minus the weight of m2 is m2g, and the sum of their masses is m1 plus m2. So if we apply that, we'll have m1 is 5 multiplied by g, which is 10, sine the angle is 60 degrees, and minus m2, which is 2, multiplied by gravity, which is 10 approximately, divided by the sum of their masses, which is 5 plus 2. So if we simplify that, we are going to have the upper version will be 43.3. That's when you multiply 5 times 10 multiplied by sine 60, you're going to have 43.3 minus 20 divided by what? 7. That's 5 plus 2. So if we simplify that further, we're going to have 23.3 divided by 7. And when we divide that, our acceleration will be given as 3.33 approximately meter per second square. That is it. So that's for the first case when there is no frictional force involved. Remember, if there is frictional force, it's only going to be affecting the mass m1 because that's the only one lying on the inclined plane. So just keep that in mind. So for the second problem, let me go ahead and wipe this to solve it. Okay, let's wipe this since we already have the fact. So for the second problem to solve it, we already know the acceleration will be given as, remember, the weight of m1 minus the weight of m2. Since m1 is greater than m2, if it is in the other way around, you just have to switch sides with the whole process. So let's go ahead and deal with this. So since there is friction, in this case there is friction, which means I'm going to have something like, it's going to be the weight of m1 plus friction minus the weight of m2 divided by their masses, m1 plus m2. So if we expand that, we're going to have that acceleration will be equal to, what is the weight of m1? We already know that, m1g sine theta plus friction. The frictional force is going to be, is given as, we know frictional force is given as the coefficient, that's normal reaction. And normal reaction, we know what normal reaction is. It is mg cos theta. So since the m here is m1, so we're going to work with that. So this is equal plus m1g cos theta. And we have, this is it for the two of them. This is the one involving this plus friction. I forgot to put the coefficient. So plus the coefficient of friction with m1g cos theta, and this is minus the weight of m2 is already m2g. So the whole of these divided by the sum of their masses, m1 plus m2. So that is it. So we go ahead and apply this formula. So I'm going to wipe everything here. So we've already established the first one. So we are going to go ahead and work on that. So acceleration will now be equal to, what is our m1g? We already know what m1 is. M1 is 5. So put that out. 5 multiplied by g, 10, sine 60, plus the frictional force, which is coefficient, and our coefficient was given as 0.2, multiplied by the mass m1, which is still 5, multiplied by gravity, which is still 10, cosine of 60, cos 60, and I'm going to wipe this answer here, minus m2, which is what? 2 multiplied by gravity, which is 10, and the whole of this divided by m1, m2, which is 5 plus 2. So acceleration will then be equal to, so if we simplify these, 5 times 10 sine 60, we've done that before. We got 43.3 approximately. So plus, so we have 0.2 multiplied by 5, that is 1. 1 times 10, that is 10. 10 cos 60, that is 5. The whole of this is 5. Minus 20 all over 7. So if we simplify further, we have 43.3 plus 5, that's 48.3 minus 20. That is 28.3 divided by 7. When we simplify that down, we are going to have 4.04 approximately meter per second square. So that is how to solve the problem. So we can see, according to the first question, the acceleration when there is no friction was 3.33 meter per second, and then when there is friction, it was 4.04 with a coefficient of friction equal to 0.2. So that is the solution to the problem. So bye bye.